Good day all, and welcome to my YouTube channel. Today we'll be talking about designing a staircase using Prota detail, and this is Prota detail 218. So we'll click on it. While we are loading, Prota details design different kinds of staircase, and we're going to see in our class today. So today we'll start by creating a new project. Click on new project. We start by typing staircase 1, and then we click on OK. And now we are going to import the design code would love to use. I love using UKBS 8110. Click on UKBS 8110 and I import the design to my work. So you click on OK. Now we are done. We're going to be redirected to a page, and this is the page, and we click on start by creating a new drawing. Click on it, and this is the page that comes up. Now this is the Prota detail page. How do we design for staircase? We go to this icon, which is stairs, and we click on it, and now a page appears on our screen, and it shows you the various kind of staircase that can be designed by Prota detail. You can see the double arm, and it has 3 different type of staircase that it can design. It has supported by the outer edge. You can see the red dotted lines. These are where the supports are. So you can design staircase with this support. You can also design staircase where it is supported by 2 outer edge. You can see the dotted red lines over here and at this other end, and you see this supported by 3 outer edge. You can see the support as dotted lines. Okay, the next staircase which Prota structure can design is the load bearing staircase. We have the separate stairs and we have the integrated stairs that is supported at this edge and at this edge. We also have the spiral staircase that can be designed by Prota details. And this spiral stairs, we have one that is supported by the outer peripheral and one that is supported by the inner peripheral. So in today's class, I would love us to start with the double arm stairs, and that is supported by an outer edge. So the first thing we need to do is to start with filling up these places, this box. Now the first one is the story height. Our story height is given to us by our architect, and I am assuming our architect gave us 30 sorry and 3000 millimeter as the height, which is 3 meter. And the width, you can see the stair width is given, but let's assume we are working with what our architect gave to us. Now you can see that this is the width of one stair, which is taken as B. You can see B, it means from this point to this point. So I would want to reduce it. Let's assume that my architect, or from the drawing I'm working on, I was given 1200 millimeter. And you can see, remember, this is also a width and this is also a width. The stair width from here to here, that's one width, and then from here to here is another width. The story landing width, this is the story landing width, is given as BSK. I can also say I want my story landing width to be 1200 millimeter. I can also say I also want my intermediate landing width, which is known as my half landing, which is BSA, to be given as 1200 millimeter. And my plate thickness, I would love to leave it at 200 millimeter. It's always given by an architect. In case it is not given, you can provide it yourself. And the plate thickness for the landing is 180, is okay. Now the stair hole width is given as 250 millimeter. I don't want 250 millimeter. I would want something like, I would want 150 millimeter, and then I go. Now for the number of stairs simply means this number 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times this other 9 will give you 18, but I would love to use 20. You can see, and when I click on this, it changes. That's 20. Now at 20, our step height, which is the rise, changes to 135. Let's assume I want to make our step rise 150 millimeter. You can see our story height has changed, so you have to be very careful. So I'll go back. Maybe I want my step rise to be 150, then I need it to be, rather than 300 I did put, I need it to be 280, and come back here, change it to 3000 millimeter. Also the number of stairs, I'll keep it at 18. You can see now my step width is 280. Let's see if I can change it to 300 if none of this parameter will change. None of the parameter change. But once I change the number of steps to 20 and I try to change the step width, which is the tread, and the step rise, which is the riser, most time the story height will change. So we should be very careful on how we play around the number of steps, the step width, which is the tread, and the step height, which is the rise. Be very careful about that. Once you play around this tree, it changes the story height. So I would always work according to what I'm giving as my architect at. I always work with what I am giving at. Like if I'm giving a drawing, I know all this will be specified properly, so there is no need for me to make silly mistakes like this. So now we have what is known as additional dead load. I'll leave it as 1500 kilonewton, and your live load should be something you as a structural engineer should know. Depending on the number of people using that staircase, it can either increase or reduce. Let's assume that we have a large number of people using this staircase. I can change it to 4 kilonewton per meter square. And now for my support width, you can see what is support width. It means the width of the beam that will be carrying these stairs. Let me assume that the width I used from my design of the whole building was 225, and the support height, which is the depth of the beam, I can assume it to be 400. Now you can see we're done with all the specification. Now for us to design, we click on redesign. You can see everything has been designed for us. This is the diameter, that is the reinforcement diameter, or your rod diameter according to layman. We can choose to change it. I can change the diameter to 10 millimeter. You can see the quantity has also changed from 11 to 12, and the spacing has also reduced from 1010 to from 110 to 100. Let's check for the next one too. Remember, it was at 13, and then the quantity was 11, and our spacing was at 110. Now let's take it to 10 as our diameter, the diameter of our reinforcement. You can see the quantity has increased, and also the spacing has reduced to 100, but I would love to leave it the way they kept it, automatic design. And now we've seen, and at this point, whatever you don't want in our drawing, we can work on it. If you don't want to see the quantity table, you click on this. You don't want anything in your detailed drawing, anything you don't want to put, you want to remove the annotated rebar in section, you can click on it over here and address any issue you want to address. But I want all this. Now you click on design report. We'll be waiting for it to load. It's going to show you the model and everything that we have. You can see our design report, the stair parameter, the story height, everything is given to to us over here. Deflection check is also given, and the load at different points is also given to us. You can see for yourself. These are the additional load, so you can see, and these are the live load we imputed, and these are the load of each of the stair arm and at the landing. You can see it yourself. Everything is given to us. Now section force, you can see the left support and the right support. The section force working on it. The bending moment is also given to you. Everything we need for reinforcement design, you can see it over here. Now when you're given this, sometimes you want to print your report. You can either print it as PDF, but I always prefer using the Word Office, because printing using Word Office helps and makes our work easy, because you can either edit this place and edit this calculated by and check by when you use the Word Office. So that is that for your design report. We click on close. Now for our detailed drawing, now we click on detailed drawing. We come to any point in our screen and we click on it. Our detailed drawing will come up, and this is the stair takeoff, and this is our bar mark number from 1 to 7. This is the size of the reinforcement we are giving, and this is the quantity we need, and this is the length we also need. All these are very important details. You can see this also shows you how these our reinforcement should be placed, giving you everything you need. Also, you can see over here, this indicates that we need 11 Y13. That's 11 pieces of Y13 reinforcement. This is the bar mark, and this is the spacing that is needed for that reinforcement, which is 110 millimeter. You can see that everything we need is all given to us here. And I know this video is actually quite the video is actually very simple. I know you've learned a lot, and if you love what you're seeing here as a means of encouraging me, I would love you to like, click, and also comment, subscribe to the channel,